Welcome to section 1.3, Slope, Rates of Change, and Linear Functions. From algebra, we have our formula for the slope between 2 points. M equals y2 minus y1 over x2 minus x1, where this is calculated between 2 points, x1, y1, and x2, y2. We can picture rise over run this way. Here's a quick graph of just the 2 points, x1, y1, and x2, y2. If I connect these 2 points, then the slope represents the steepness of that line between them, and the run is that distance between x2 and x1, which is x2 minus x1, and the rise is that distance between y1 and y2, which is represented by y2 minus y1. On the graph, we can break that slanted line down into 2 pieces, the horizontal change and the vertical change, and that's the run and the rise, represented in the slope formula: rise on top, run on the bottom. So here's possibly some new vocabulary. A line with a positive slope, that's the same as m, a number m being greater than 0, is called an increasing function. And a line with a negative slope, that's another word for m being less than 0, that would be called, the line itself is a decreasing function. And a horizontal line has slope m equal to 0 and is called a constant function. So we've got our increasing functions, always look left to right. So this goes up to the right. A line with a negative slope goes down to the right. And a line with 0 slope, we don't say no slope, but with a slope of 0, doesn't go up, doesn't go down, it's horizontal. From an equation, y equals mx plus b, we can read off the slope. So that letter m in y equals mx plus b, the number next to the x, is indeed the slope. So in this example, y equals 3x plus 1, we can read off the slope, m, is equal to 3. But what about the equation 3x minus 2y equals 6? How do we find the slope of this equation? We've got at least 2 ways of finding the slope. And we'll do this problem twice just to again remind you of a few things from algebra. So first of all, using the equation, we're going to solve for y. In other words, put 3x minus 2y equals 6 into y equals mx plus b form. So copying it down, 3x minus 2y equals 6, subtracting the 3x, keeping that negative with the 2y, we get negative 2y equals, and to make it look like y equals mx plus b, I'm going to tuck the minus 3x in front of the plus 6. Then I have to divide everything by that negative 2. And on the right-hand side, I like to show that by dividing each term by the negative 2 so that I can keep all my signs straight. So simplifying, I get just a y on the left. Negative 3 over negative 2 turns into positive 3/2 x. And then positive 6 over negative 2, that turns into a minus 3. So there's one option. And now I can see that the slope is now 3/2. I can just read that off. Okay. In the second version, I wanted to remind you about the idea of an intercept. An intercept is where a line crosses the x or y axis. So a point on the x-axis is an x-intercept. And in particular, we've got whatever the x value is, but y has to be 0. And if a point is on the y-axis, then that is called a y-intercept, and it will have some y value, but the x value has to be 0. All right, so since we know one of the coordinates, we can use our function, our equation, to get the other value. For example, if I plug in x equals 0 to find the y-intercept, it might be easiest to use the second version of the equation, y equals 3/2 x minus 3, and then I can see y equals -3 pretty easily there. You could also plug it into the original equation. If you plug in 0 for x, 3 times 0 is 0, and then -2 times a -3 is what will give +6. And then to find the x-intercept, I can choose to put the 0 in for y. That's a little harder to do with the y equals mx plus b, so I might plug that into the 3x minus 2y equation equaling 6, and then I can see, oh, x has to be 2. So there are my 2 points on the line, 0, -3, 2, 0. Then the slope, I can use my formula up at the top, subtract the y values. Doesn't matter what order as long as you're consistent. I usually take the second value minus the first, so 0 minus -3. And then on the bottom, 2 take away 0. So again, if I go bottom to top, I have to do that on both parts of my subtraction. So that gives me a +3 over a +2. And there's my same slope, 3/2. Okay. Now, as it turns out, slope is going to be an incredibly important concept for us. We're going to spend all the way through chapter 4 and again in chapter 7. Slope we're going to return to over and over and over. So we're going to delve a little bit deeper into it right now. So using function notation in the slope formula, we can use f of x in place of y. So if we take a and b as some number, 2 different numbers, then we can use our function notation and show that we're plugging a into our function f of x, and we're plugging b into our function f of x, and we get f of a and f of b as our y outputs. So instead of using y, we're using f of x. And then the slope formula becomes, oops, sorry for the movement there, m equals, now I'm going to subtract these y values in their function notation. So instead of y2 minus y1, I have f of b minus f of a. And on the bottom, I'll use my letters b minus a instead of x2 minus x1. So here's a function notation version of the slope formula. So just helping us stay focused on the fact that we're looking at functions. Now, the slope of a given line is a fixed number that never changes. A line has a certain steepness, and that's described by the slope. And that never changes no matter which 2 points are used. Calculate any 2 points, the slope will always be the same. But what does slope mean for a nonlinear function? This example at right is a parabola, some sort of x squared function. All right, it goes down and then it turns around and comes back up. Definitely not a straight line. So consider f of x equals x squared minus 3. That is this particular graph. F of x equals x squared minus 3. Okay. If we choose any 2 points on this parabola, I'm going to arbitrarily choose a point down below and a point on the left and a point up above the x-axis on the right. Pick any 2 points, I can see that the graph itself is going down at my left-hand point and coming back up at the right-hand point, but I can connect those 2 points with a straight line, and this slope between those 2 points, where we have a comma f of a for the first point, b comma f of b for the second point, the slope of that line is the average rate of change between x equals a and x equals b. So when we say average rate of change, We're just talking slope. And the calculation for this is also called a difference quotient. So yet another word for slope. So all three of those have to be put together in your head. Slope, average rate of change, difference quotient. And that word difference quotient, in mathematics, difference usually means subtraction. And then quotient means a fraction. So yes, we have created a fraction with subtraction with our slope formula. That's where that comes from. All right, we're going to continue looking at a specific example working with this parabola on the next page, but I think I will go to part 2 to do that. See you then.